Hello, am I audible? Hello, hello, am I audible? Can anyone tell me am I audible or not? Can anyone confirm me? Hello, am I audible? Can anybody give me a confirmation? Hello. Okay, let's get started then. Very good morning, a very good evening to everyone. A warm welcome from Hyderabad SolidWorks User Group. This is Syed Shafi Hashmi, leader Hyderabad SolidWorks User Group. Today's session is a special one with an exceptionally speaker. Since we have been inactive for a few days or months, so we have decided to organize a session on a particular topic, which is one of the hardest or the most difficult exam SolidWorks probably is mold making. It's a professional advanced exam. So today's session title as deep dive into mold making is a SolidWorks uh, professional advanced exam. So this session will uh, explore the essential tools required to clear the mold making exam. Okay. Uh, by the end of the session, the attendees will gain the insights into advanced mold making design techniques and the strategies required to clear the exams. Even if you are not giving the exam, you will gain the wonderful knowledge about mold making, which is one of the hardest topic of SolidWorks. Okay, so when it's come down to the speaker, he's a exceptionally special speaker. He's a SolidWorks champion. He's a mentor for Startup India. He's a professional freelancer. He's also a specialist in product design, design for manufacturing assembly, special purpose machines, and finite element analysis. Okay, so guys, welcome the man blessed with exceptional skills, Prabhakar Purushothaman. Welcome, sir.
Thank you, Said Shafi Hassami, for your wonderful introduction. Good evening, good morning, and good afternoon, all the peoples who have joined all over the world. Hope my voice is clear and audible, right? Said, can you confirm whether my voice is clear? Yeah, I got some message. Fine. Thank you. Thanks for the confirmation. So the introduction was already given by Mr. Syed. So I don't want to take much time about providing myself about on the introduction part. So I will just share my screen. Hope my screen is visible. First of all, I thank Hyderabad SolidWorks user group team for giving me the wonderful opportunity to present to you all. I feel it was a great moment to share my knowledge and experience with you all, the team members who is attending all over the world. So, myself, Prabhakar. So, I am SolidWorks expert and also SolidWorks champion. This is my LinkedIn page and mail ID also I have provided. So, first 15 or 20 minutes, I will take you to a PPT and explain you about the basic principles of the mold. Then we will deep dive into practical solutions, problem solving techniques, what to be used, how to be used, see in the SolidWorks itself directly, and we will take it forward. That's how the session is being planned. So this session is little bit larger session. Like usually it will be in a 1 hour session, but we are planning it for 2 hour session. So that, please bear with me throughout the session. If you have any doubts, at the end of the session, we will have like 10 minutes time where you can, or in between also you start posting your queries in the chat box. So everything I will address then and there, or at the end I will address all your queries. That's how we will plan for today's session. So agenda of this today's session will be a quick introduction about mold. What is mold? How the mold construction between will be there, and what and all the parts will be there. Everything a quick introduction we will see. Then exam preparation steps. So what, how to prepare for the exam we are going to see. Then directly we deep dive in the demo in the SolidWorks itself. You will take the problems, similar problems which you are going to face in the exam. The similar problems we will take and we will address those problems. I will give you a practical live demonstration. This is how the session is being planned for today's session. So first, what is CSWPA mold making exam? It's an industry focused exam which includes the challenge and data that test your mold making skill, especially the mold industry knowledge using the SolidWorks. The SolidWorks is main for all kind of industry. One of the industry SolidWorks supports is mold making also. So for them to test the skill, this mold making exam will be very much useful. So what and all required for the SolidWorks mold making exam is like parting line creation. So parting line creation, cavity tool, draft analysis, undercut analysis. There will be some of them who will be completely new to this mold making. So who will be not at all even able to understand what is this parting line, what is this cavity tool, what is this draft. No need to worry about all these things. So at the end of the session, you will be coming across all these things, and everything will be covered here. So that I can guarantee you. So practical live demo will be shown. So the major requirement is these things. So we are going to create the parting line. Okay, what is the parting line? So whenever the component is been created in the mold, the component has to be ejected from the mold. This ejection creates a line on the component. All line will be created on the component. Any plastic component injection mold will have this parting line. This line we call it as a parting line, which is nothing but due to the mold half opening and closing, the daylight will be formed. We call it as a daylight, the gap formed between the mold, fixed half and movable half. There will be two half in the mold when it is loaded in the machine. One half will be always fixed side, it will not move at all. The other half will be moving back and front so that the component from the mold can be ejected. So this ejection creates the line which is called the parting line, which is formed at the parting surface due to the mold opening and closing. And cavity tool. Cavity tool in creating the core and cavity, this will be helpful. Then draft analysis. For injection molding, again, we'll be providing the draft. Okay, what I will do is I will take you through the injection molding thing. Then we will come back to this, so that or anyway we are going to see all these problems in practical demo. So that time we will be able to understand. So coming to mold making exam, total it has 14 questions, and maximum points is 160 points. To pass, you need to score at least 120 points requirement. This is the criteria. So so out of 160 points, you have to score 120 points so that you can clear the exam. So coming to injection mold. So plastics are processed in many processes like injection molding, compression molding, transfer molding, thermoforming, calendering, and so on. But this exam is completely focusing only on the injection molding, not even the compression and transfer molding. So the difference between the injection mold and compression mold and mold, the main difference will be the thermoplastic material. The plastics can be broadly classified into two. One is thermoplastic, the other one is thermosetting plastics. So thermoplastic material, usually 99% will be formed using the injection molding process. Okay, thermosetting plastic usually will be either in compression molding or transfer molding process will be followed. So in the major difference between injection molding and compression molding will be, in injection molding, the material will be fed in a injection molding machine, and the hooper and barrel will be there. The barrel will have a heater. There the material will be melted. A screw will rotate, and screw will inject the molten material into the injection mold. Suppose this is the area, we call it as a register ring. So this will get locked into the injection molding machine, and this is the top plate. The top plate and register ring will have a fit. So this outside will be locked onto the machine. There will also, it will have a fit. Here H7 will be the top plate. H7 hole will be maintained in the top plate, and P6 will be maintained in the register ring. And also next part comes to the sprue bush, the tapered portion, which will be the entry of the plastic material. So material enters here through the sprue, then goes through the runner, passes through the runner, then gate, then finally fills the component. That's how the material entryway and exit way, which means the ends that fills the component. So material enters as in sprue, then runner, then gate, then comes the component. This is how the material completes the component. So most of the time, multiple cavity mold will be there. In a single shot, multiple components can be provided. Such molds, we call it as a multiple cavity mold. Single cavity mold means in a single shot, one component, only single component will be formed. That's what we call it as a single cavity mold. Okay, so there will be two half. One half is core half, another half is a cavity half. So here the projected part, we call it as a core, which means the projected part which create a blank or empty space in the component, which is called a core. The core is something which create a space, empty blank space in the actual component, final component. That's what we call it as a core. And cavity is the one which will create the external outer surface. So between core and cavity, a gap will be formed. In the gap only the material gets filled and the component is being formed. So in the mold, one thing we have to understand is always the component will get stick to the core. Component will not be getting stick to the cavity. The reason is we are injecting the mold. Hot molten metal will be injected into the mold, and material gets filled. And once it is filled, it gets solid during the solidification time. Again, in the mold, there will be a cool water plugs. Water lines will be passed. Why means the molten metal will be almost like, suppose for an example, 100 to 150 degrees Celsius based on the material selection, it will be injected. So this temperature will keep on increasing the mold temperature. In order to maintain the uniform mold temperature, water cooling channels will be circulated. For example, this is a water cooling channel. Water goes in, comes here through the pipe, then cools this core, then goes here, again cools here, then goes out to the outlet. So such a way the cooling will happen. So the mold is also cooled, and also when the injected mold is at the lower temperature, the material is at the injected plastic material is at higher temperature. So heat transfer takes place here. The component gets cooled here. When it is cooled, the component will shrink. So when the component shrink, the dimension slightly reduces, and it will get stick to the core. So what sticked? As I told, the component of the mold. One is core of, the other is cavity of. Here, the pink color portion, that will be the fixed off. The other one is the moving off. So the moving off will open up. So there will be a gap will be formed. Then through the ejection pins or the sleeves, there are various types of ejection method. Sleeve ejection, pin ejection, so many ejection types are there. Any one of the ejection method, the component will be ejected from the mold. So not only the component, the sprue area, runner area, everything together, it will be ejected from the mold. This is the basic injection manufacturing process. This I want you to understand. This is how the mold works, and basic mold manufacturing process will be like this. So if you want to understand in deep, this is the registering, this is the top plate, cavity plate, usually cavity back plate also sometimes will be used, and core plate. This is a core back plate, and both sides there are spacers, ejector plate, ejector back plate, rest buttons will be there, so that the instead of entire plate getting butted to the surface, small buttons will be kept onto the button, will be rested. Then this is the bottom plate, and this to actuate this ejection pins, this there will be a rod and connection will be there from the injection molding machine. This is how the entire two plate mold. There are again in an injection mold, there is a 2 plate and 3 plate. That also we will see when we do some practical examples. Hope I have given in a short time a quick introduction about the injection mold. Injection mold is nothing but, if you want, in a simple way, if you want to understand, means we are making ice cubes just by filling the water. The same thing in what we do is between the steel plates, a plastic material is injected, and the plastic material will get filled between the steel plates wherever the projected area, so that the component will have a undercut or gaps. That we call it as a core. The complete gap area we call it as a cavity part. That's all. So we will directly drive into the exam preparation step. The first will be like a complete mold will be given, a 2 plate mold given, which will be of multiple cavity mold. Usually you will be instructed to create a component from the mold. Only the component you have to create. Then you have to apply the material and adjust the shrinkage. So what is shrinkage? I already told you, like suppose if you have a component of 100 mm diameter, final requirement is 100 mm. If you do injection molding, create a cavity with 100 mm, what will happen? While plastic material gets solidifying, it will shrink. The material will shrink because the bonding, due to the bonding of the plastic material, the polymer, it will shrink. It will, while it is shrinking, the dimension will also get reduced. You may get like 99.9, 99.8 mm only you will be getting. So how generally the people overcome this difficulty is, they will oversize the dimension, which means suppose if they need 100 means they will maintain like 102, 100.2 or 100.3 mm based on the shrinkage factor. For each every material, they will be giving a shrinkage value, which is a standard is available. Based on that shrinkage value, the factor will be considered. Suppose 100 mm required means 100.3 will be molded. So when it is shrinked and cooled and ejected from mold, final dimension will be 100. That's how it will be maintained. So here also what they are asking is we have to consider the shrinkage factor, and shrink rate also is being given. Considering this value, we have to provide the final mass of the component. That is the requirement in the exam. I will take you to the SolidWorks. Meanwhile, I will just see if you have any queries. So much. Okay, there is no much queries so far. So far, everything is good. If there is something, please drop in the chat box. Now I will go to the SolidWorks directly. So as I told, the first question will be like the entire mold will be given. This is the two-plate mold. So in this, the idea is you have to create one single component from this mold, entire mold. You have to suppress and remove the unwanted parts, everything, and create one single component and assign the mass and also assign the shrinkage value. Then enter the value in the grams. That will be the question. This will be a 20 points questions. The first question usually will be of a 20 points question. So we will directly, I will solve it for you. So if you see here, as I told you, it is a two cavity mold. So this is the sprue. This is the sprue I am telling. The material entry point is this point. So material comes here and till here, it goes here. This is the runner, and this edge point area, we call it as a gate. Then it fills the entire component. There are two halves are there. This is one half fixed off, and this is moving off. The bottom half is moving off. Okay, so there now for this question requirement is we have to create one single component. That's all. So very first step is what I suggest is you can directly do the box selection and suppress the unwanted area. Okay. So these are all the parts which is not at all required for me. So I just taken the core and cavity insert, and so here the arrangement is, I cannot say both are cavity only. So core is side core. This is what we call it as a finger cam. Using the finger cam, the side core will be moved when the mold is opening. So here there is there is no single fixed core itself. Moving side core action is there, and both the side cavity is there. So even I don't need this parts also. So why I was insisting on the mold parts, the reason is you should know which parts needs to be suppressed, which is not to be suppressed. So again, I am going to create one single component only. So I'm just suppressing the one complete side. So I have taken, you can see here, for one single component, whatever need to be there, this is a handle of a bike. So there should be a opening should be there. Then there should be a material should and fill this entire cavity and the component should be formed. That is the requirement. Now we are going to create the component. So for that, what we are going to do is insert component, new part. Okay, select this and just you can create just above the just covering the component. You can create a rectangle randomly. Okay, then extrude, you give up to surface and select the bottommost surface. Then the very next step, without exiting, just cavity, enter the command cavity and select all the parts. This warning will come because I'm selecting the own particle. So just give OK. Here you can give the selected bodies and select whichever the bodies. Only this portion is required. This whatever created here I can ignore. So I select that one particular one and give OK. Now I exit it. I'm opening here. You can see that the component is formed. In SolidWorks also, some of them you will, if you are not finding this mold tool, just right click in this blank space. You can find this mold tools. You can activate this. And also I suggest you to activate this direct editing also. So because this direct editing, you'll have delete, keep, delete face command you can use. Here delete and patch command I use, and I select. It will show the preview also. What it does is, you can see here exactly, it will patch also at the same time. I will do it again. So delete face, I select this face, and this face. Delete and patch command I used. So you can see that exactly it cleared. So now the component is being completely formed. The very next step is, I am showing in the PPT, the shrinkage rate is 0.05. As I told, when the component shrinks, the dimension will be reduced by 5%. That's the meaning. So what we have to do is scale. We have to scale the component now. So what you have to do is, the value has been given, so 005. Directly add to this. Then apply the material. Material, they have given it as a ABS. You go to plastics and ABS, apply the material. Then I go to evaluate mass properties. I will get the weight of the component. This value I have to enter as a value. This is how the first question will be. You have to answer. Hope you got an idea how to create a component, single component from the entire mold. I will see if I have some other problems also. I will try to solve. Okay. So this is how you are going to address the first question. The first question will be, the entire mold will be given. So here in that you should take only the core and cavity, and from that core and cavity have to create a single component. So if people who have missed, I will show you once again also, if you are not able to follow me. So most of the time, if you ask how quickly you can do is, this bottom half plates completely you can suppress it off. It won't add you any value to for creating the component. So without thinking, this you can suppress it off. So these three plates also, because most of the time within the inserts only the component will be formed. Why? Because whenever, due to the wear and tear, when the material is passing and filling the mold, there will be wear and tear. Instead of changing the entire plate, most of the time the mold will have a inserts, core inserts and cavity inserts. sorry. So the inserts will be there for sure. So keep only these inserts, and all these pillars, everything you can directly select and you can suppress it off. Then one set is sufficient for me. So the second set I just suppress it off. Then unmounted screws, suppress. So the first step is insert component, new part. I select the surface, just creating over the component. Then I go to features, extrude, up to surface I select, and till the surface is selected. I'm not exiting from the part command, directly I just select the cavity. I go to cavity tool and entire thing is selected. This warning, you just give OK. Select. If you give all bodies, you have to delete these things. Instead, you can go to select bodies and select only the main portion, which is highlighted and shown here. Now you exit here, then open the part, then go to direct editing, delete face. You select the delete and so automatically it will be deleted. Also, it will be patched. Then the very next step is apply material. Whatever the material has been given, that you apply. So here I just randomly select ABS PC. So then the scale factor, considering the shrinkage value of the material, increases scale factor. You can see here without scale, the mass is like 56.68. After scaling, 7.54. So we oversize and mold the component, but after shrinking, it will get reduced. And the mass will also get reduced. The size will also get reduced. That's the thing I like here. Because from liquid to solid transition happens, there is a shrinkage happens into the plastic components. Hope everyone understood this first question. Next, we will move on to the second question. So the second question will be like creating the shut-off surfaces. What is shut-off surfaces? As I told you, the component will two halves. One is core side, the other one is cavity side. So this shut-off surface defines till which area the core will be projected in the component, which is the cavity surface, which will be the core surface. That will be defined by these shut-off surfaces. Okay, now I will just see if there is some question. Can you explain the part once again? I hope a second time also I explained. That is clear, Mr. Anurag Bal. Then we'll move on to the second question. This question is also of 20th question. Here also one component will be given to you. Okay, for an example, a component will be similar to this will be given to you. You have to create a shut-off surface, which to be created, that also some images will be defined in the question itself. For an example, the shut-off surface will be this. So till here the core will be projected, and above that the cavity will be formed. So parting line will be exactly formed on this area, and also exactly on the radius ending area on the outer surface. So both the radius ending area and the inner surface and outer surface will be acting as a part. So for creating the shut-off surface, directly just go to the mold tools. So shut-off surfaces will be there. So it usually, when you select it, automatically select your clear selection. You can select it. You have select as a chain. So I'm selecting a continuous chain. So without leaving anything, any small segment, if you have to create a, so these two surfaces been created. Now the same way I follow and create it for the third surface. So here the answer is you have to measure the total surface of the area of the set of surface and enter that value. That is the requirement in this question. So there are 4 set of surface to be created here. So I have selected. So finally, I just give a tick mark. So then I go to measure and select surface 1, surface 2, surface 3, and surface 4. This forces value. That value I just 1381.96. This value I should enter as a answer. That is the requirement in the this thing. This is a straightforward. I just selected the set of surface and continuously selected the loop, closed loop. So I got the answer. Sometimes the key question also. For an example, I will open one more example. So I have chosen some problems also so that you get an answer. Here you can see that here what can be the, where can be the set of surface. If you ask means, you can see that there is a taper here from the top to the, and also there is a taper from bottom to the middle. This exactly, if you see the cross section, even if you want me to show a cross section, I will show a cross, take a sectional view. You can see here, this there is a taper here and the taper here. So the parting line should exactly fall in the middle of this region, because so that the component can be ejected. So one half will be in the cavity, the other half in the other side of the cavity. If you, for an example, if you keep the parting line here, the material here will not get ejected. Material will formed after the forming, because this area till here, the steel metal will be there. Exactly, if you keep the parting line here, then only the component can be ejected. That's the logic here. So I hope this you got an idea. So the shed of surface should be exactly in the middle of this. So if I see here, one thing I am missing here is this area I have to split. So what I can do is I just go to the front plane, surface. I use split line. In the mold tools only, I use the split line. For that, I just go to front plane, split line command I use. For that, first step is I have to create a sketch. So how I create is just I go the perpendicular to the parting line. The parting line wherever is required, perpendicular to that one plane I select. Then just create a line over the plane. I select a midpoint so that both the side it will be created. Then I created go to the mold tools, split line I use. I select the faces, the entire face I have to select. So completely I selected. Now you can see that a line is being created completely. Okay, now I'm just going to shut off surface. So automatically it will select, but I will clear the selections. While selecting carefully, you select the edges. Don't select unwanted edges. That will create an issue. So this surface has been created. If you give tick mark, this shut off surface will not be working. But also be careful. So if you want to, in between, if you unknowingly given tick mark, just right click edit, then create the shut off surface over here. So here I have not splitted, so it won't get created itself. So again, if you have done such mistake, no need to do anything. Just once again go here, just edit it here, select, then come back here, complete the selection. So if you are not getting straightforward split, then you can use the split line option, which is available in the mold tool. That is one thing I like to highlight. So due to time constraint, I just stop here. So finally you have to do just measure, and also you have to do the shut off surfaces holes also. Once it is done, measure everything and type the value. That's only you should understand. I want you to understand here is, so like the earlier component, it was completely clear. The parting line, the intersecting line was passing through. But for this component, for such complicated component where the lines are not there, you just select a perpendicular plane and draw a straight line. Just midpoint I just taken and draw. You need not exactly stop. You can no need to worry. Then go to the mold tools itself, split line command use, select the surfaces. So randomly I select some surfaces now and I will show you. So once you select, automatically whichever the surface is being selected, you can find the line. So once you create it, you select those continuous chain, closed loop, then you'll be getting the shut off surface. This is how you have to create a shut off surface, and you have to enter the value of the shut off surface. That's how the requirement for this also be your second question. This will also carries 20 marks. Everyone can easily score your marks. Now we will move on to the third question. Hope there is some questions. Yes, the split surface you can split. There is a question from Rofin Nabi. You can split the surface. It's not at all a problem. If the split surface doesn't works, then the easiest option I was recommending is the split line. Example, there is a question: how does we calculate that how much shrinkage will occur for polypropylene? Nothing. You need not to calculate anything. If you type shrinkage in the shrinkage value of poly, automatically you will get that value percentage. So again, due to the additives and fillers, these values will be keep on changing. So the material data sheet will have these values. You will be getting the data charts. For an example, ABS material minimum value is 0.7. It can shrink up to 1.6 percentage. So polypropylene, go here, and if I say check, usually the mean value will be taken by the user. The polyamide, they have 0.3 percentage of shrinkage. Polypropylene, again, homopolymer, copolymer, there are so many things. So 2% to 3%. So again, it varies. Glass, when it's a glass filled, again, okay. So this is how it's a standard value. We need not to calculate it. So based on the material manufacturer will provide shrinkage value that we consider, and we have to oversize the mold when we do the mold. I hope I answered Nisham Aram. If you have to do after I could command this, I am not exactly answering. We will discuss later. It's a practical shut-off surface. Is the how it will be helpful is while creating the core and cavity. This shut-off surface plays a major role. Anyway, the next question will be on that. We will address that also. You will be coming to know how exactly the shut-off surface in the mold. We are going to see that. Okay, now without much delay, I will move on to the next question, and we have a time constraint also. So quickly we will move off. So the next question is, we have to create a parting line. So this question will tell you the importance of the shut-off surfaces also. So the creating the parting line is crucial. It defines where the mold separates into the core and cavity house. How the mold is separated between the core and cavity, and also how when the parting line is there, only we can eject the component. Without parting line, the molded component cannot be ejected itself. That's the reason the parting line will be provided. Usually the parting line, how it will be decided means, for an example, if you have some doubt, I will take a paint. If you are molding a cylindrical component, exactly a ball, a spherical component, we will assume. If you are taking a spherical component, the parting line will be exactly at the middle of the spherical component. Why exactly middle of the spherical component? Why not above or below? The reason is, when the two half opens, the component should be ejected. If it is slightly above, imagine if the parting line is slightly above, the component will be formed. This half will be open. The moving half will get opened. From the fixed half, you can see here, this area, the material will be there. Till this area, the material will be there. steel material will be there. It will not allow you to eject the component. Okay, so that's why we are recommending to select the parting line exactly at the middle of the part, so that when both the half opens, the components can be ejected. So the parting line decides how exactly the components can be ejected from the mold. So here the task is you have to create the parting line, and you have to create a core and cavity. Core and cavity also you have to create from the component whichever is been given. The size of the core is been given, like X is 150, Y is 200, Z is 45. You have to apply the material to the core as chrome stainless steel. Finally, you have to find the mass of that is the question. So I will directly take you into the problem. So this is the component. The component will be given into the question itself. You have to just download and use the component. So the first step is they have asked you to create a parting line. So where exactly the parting line to be fall also they will be defining you. Most of the time this value will be given. Direction of the pull will be front plane, and the draft angle as 1 degree. So this is the direction of the pull. So if I place here, I will show the direction of pull, the plane. I should select the front plane, because to this direction only the parting line to be created. And this draft analysis, if I automatically the edges will be selected and it will create a parting line. You can see here the part is being created onto the component which is highlighted in the blue color. Once the parting line is created, the very step is for creating the core and cavity, I have to do the shut-off surfaces. So when I click the shut-off surfaces, automatically it's selected, and all this looks fine for me. You can see here, it exactly takes the inner surface, inner, and this is also inner. Once I give the shut-off surface, you can see here which is cavity surface and which is core surface. Everything will be defined here. The green color represents the surface which is touching the core. The red color represents the surfaces which will be touching the cavity. So between this red and gray, the material will get filled, the component will be formed. That is the idea. That's what this coloring indicates here. Hope this is clear. So someone has asked about the importance of the shut-off surface. The shut-off surface will decide which surface is going to be act as a core and which surface will be act as a cavity. So this cavity will have this projection also, which means this projection, the steel material will get projected in this area. So that's what it defines. It won't comes from the core area. That will be defined by using this shut-off surface only. That is the importance of the shut-off surface. So the color indicates the cavity part, and the green color indicates the core part. Okay, so I have created it as we discussed here. So we have to create the core and cavity of and find the mass of the core. So first step, I created the parting line. Next step, I created the shut-off surface. The next step is parting surface. I have to select. Parting surface, I just select a tangent to surface, command directly, and here there is some value has been given 150, 200 and all. So randomly I select like 75 mm. 75 mm means each side 75 mm, 75 mm, 75 mm, 75 mm, all the four side minimum 75 mm direction it is being projected. Okay, so it is being created. The next step is I have to select the tooling split and select the surface. I'm going to rectangle, center point rectangle. So then I'm going to enter the value like 150, 200. 150 and this will be 200. Okay, once I exit the sketch, automatically automatically it will show the value. It's auto cavity direction also 45, and 45 is there. In the question also is 45 only, so I just give OK. So the core cavity with component will be formed. So if you see the solid bodies, so I will just hide this shut off surface. This is component. This is cavity. Component also I will hide. You can see here the core portion. And this is the core. You can see here the component. This is the core. The bottommost thing is a core and component. And if you want me to show the cavity also, this is the cavity. So in between, this is the component is getting formed. So here the question is like we have to find the mass. So by applying the material also. So I can apply directly material to that body. Chrome carbon steel was the material I had just taken. So just selecting that chrome carbon steel. Then evaluate mass properties. I go. I select only this particular part. So I get the mass. This I have to enter it as a value. This is how we do it. We create the core and cavity with the component and assign the material to the core and check the value and enter the value for the core. This is somewhat simple component. Some advanced level components also I have taken. So we will see the second component. So people who have missed earlier, just follow this, try to follow this. Component is given to you, something like this. So directly go to the rules, go to parting line. Here also it has been given with respect to top plane. Earlier it was front plane, now they have given us a top plane, 1 degree angle, whatever the value. This will be as an input, so don't need to worry about which plane and the draft angle, everything will be provided. Here again you have to select here, earlier last component. If you have seen, it automatically selected and it was okay for me. I just given the tick mark. Sometimes you may have to manually select. It won't, auto selection won't work. So which to be selected anyway, they will be given in the question itself. So where exactly the parting line should be covered, everything will be in the question. So no need to, you need not to worry about it. You should get any warning over here, which means your parting line is correct. So I manually selected and created the parting line. The first step is when you get the component, go to the parting line command and create the parting line. How to create, already told you, just have to select the plane. There will be a draft analysis, click here. If the edge is automatically selected and if it is okay, just give okay. If not getting selected, you do manually and create the parting line. Once the parting line is created, the very next step, just remember the command itself in the program. you just go to shut off surfaces. Okay, so which to be shut off, then that also will be properly defined. So most of the time auto selection won't works. The earlier component auto selection was okay, so I just selected here. Now here I need to do manual selection. Just select here and selecting the loop. Same way, selecting here and selecting here, clicking on the loop, selecting here the loop. So shut off surface is being done. So till this surface, the cavity will be core will be projecting from the core from the side, top cavity side will be projecting, and in the core side it will get stopped here. There will be a complete blank material will come and close here. That's what this shows. So now we created this. The very next command is parting surface. Again, so how much size we should extend that? Suppose 50 or 75. This is little bit complicated thing. So what we have to do is perpendicular to pull you should select, and you should go with manual mode. Okay, perpendicular to pull and manual. Earlier tangent to surface itself it was working, so directly used. This is not a direct component. It's slightly tricky one. So what we have to do is just drag place. It will show where exactly you need to place it. Okay, the same way this manually you can adjust it. I'm just manually pulling it. How you exactly know means you can see here the line. So the line starts here, it goes somewhat an angle, but I want it in a straight line. So it's still slightly, if I move, there will be a pivot point. If I move slightly near to that pivot point, automatically it only pull and it will take to that point. I need not to. Okay. Just checking whether still something I'm missing. No, let it be here. So time being, okay, the shut off surface has been created. Then, sorry, the parting surface has been created. Shut off surface earlier only we created. Parting surface we created. Then tooling split, selecting the surface, making a rectangle. So whatever the size, the dimension has been given to you. Suppose 250. I'm randomly giving this number. 150 something has been given means you take that value, just exit the sketch. When you exit, automatically this value changed. If they have given some value like 50 by 50, core side 50, cavity by side 50 means you enter that particular value, give the tick mark, automatically the core and cavity will be created. So I just hide this for easy reference. So you can see here, take a sectional view and you can see it here. The component, the core and cavity. In that, if you want to assign the material only for core, just right click here, the material with its plain carbon steel randomly apply. Then go to evaluate mass properties, clear selection and select the core or cavity, whichever is being required. Then enter the value in the grams. So this is how you need to address the question. Hope this is clear. We will move on to the next question. Yeah, fine. So next question will be calculating the maximum distance. You will be given a mold and you have to calculate the maximum mold distance. So the complete mold will be given. Usually a 3 plate will be given as a problem. Whatever we were discussing till now, it's a two-plate mold. A three-plate mold, for an example, if you want me to tell me. There will be two daylights. Okay, this is a three-plate mold example. So one daylight is for ejecting the component. The other daylight will be for ejecting the sprue. This is how the two daylights will be created. So one daylight is for ejecting the sprue, runner, gate, and all. The other, which means automatically the component will be removed, which means usually when in two-plate mold, when the component is removed, in a two-plate mold, if you see, this is the component, the sprue, runner, gate will be there. So component will be separated as a secondary process. But in case of a three-plate mode, this component separation and along with the sprue, runner, gate will be done automatically. So in two-plate mode, there will be only daylight. Like for an example, I'll just go here only. So day is nothing but this is a daylight. When the mold opens, the gap formed between the mold, we call it as a daylight. So there is a single daylight. So there will be single gap formed between the core and cavity in two-plate mold. That's why we call it as a single daylight mold. To three-plate mold, two daylights will be. One gap is for removing and ejecting the sprue, runner material. The other gap is for ejecting the component. Usually a three-plate mold will be given to you and they will be asking you to find the distance, maximum distance. At opened condition, what will be the maximum distance between the top face of the top plate to bottom face of the bottom plate of distance to be calculated at opened condition. So here also a quick thing we need to understand here is, like already we discussed in the mold, this is a 2 daylight mold again, sorry, 1 daylight mold, single daylight mold, 2-plate mold. The bottom of almost everything will be fixed. The top will be in the top. So almost all the components will be moved in the top of. So that we need to understand and we need to quickly do it. I will do it and show you. It will be a bit tricky, but you need to practice. If you start practicing, you can able to complete address that question also. So I will open that question. So anyway, I'm taking time. The reason is this is also a 20 minutes, 20 marks question. So whatever we see so far is 20 marks question. All are like 80 marks. You can easily score. So instead of rushing and skipping something, I want to give in-depth knowledge so that you can clear the exam in very first time itself. This is the solved answer. So how I solved it, I'll just show you from the only. So you will be given a mold, complete mold like this. So in the mold, as you know, this is the top plate. Okay, and there is a guide pillar. These are all the guide bushes. Okay, so the very easy step is you have to make it float. So whichever the component you are going to use, you have to make it float. The first component you are going to use is this register ring and top plate. So I will change the transparency. Then I just made it. Go to assembly, just give mate. This will be butted against this and it will be concentric. Then the next thing I make a float is this pillar. Not all the pillar I'm floating, just one single pillar I just float and made it to the, this pillar will exactly fit it to this area. Next is, for my easy understanding, I will float this just to, actually this component I need not to float. This is a sprue puller, we call it as. This component name is sprue puller. Little bit difficult to people to remember, but still just keep a pace with me. I will explain you why exactly it is used. When the injection molding happens, this retains the sprue. Next, I float this part. You can see here how this sprue puller will function. I will tell you. When it is, there is no gap. Imagine it is closed like this. The pin will be projected here. The molten material will comes through here, comes here and fill here. This will catch the runner portion and all the four area. When the mold plates opens here, it gets ejected. So how it opens? Based on this limiting pins. So this limiting pin matters. This limiting pin will but on this surface. And this bottommost step portion will but here, which means this will have a threaded male thread here. The pin has a male thread, the plate has a female thread. The next part I make a float is this pillar bush. The next pin is this pin. This plate, core plate, I make it float. For my easy understanding, I just change the transparency to normal mode. And this pin, I make it float. You can see that there is this head will come and butt against this step. Also, I'll make it concentrate to this. Then this will also a threaded pin. So it will exactly butt against the stop here. Okay. The next, to stop this plates, this pin will act. So I'm just floating this. I will take a cross section and I will show you so that you will understand step by step. This will come in exactly, but over here. Okay. So one by one, I will take a section view and I will show you. The first limiting pin we saw is this small pin. See here, this small pin, why it does is this sprue puller has to eject the runner and gate, sprue runner and gate. That's why this pin made a gap. When it is closed, this pin will be projecting till this space. I will keep normal. The pin will be projecting till this space. When it is butted here, it acts as a stopper. Further, it will not, this plate will not move down. That's the first restriction. The second restriction is this plate to this plate. So this is a cavity plate. So cavity insert will get fitted here. So the cavity plate is stopped through this limiting pin. So this will have the pin will have a male thread. So it will hold this plate. That's how this plate is being stopped. And again, this plate to core plate, the relation is being created by means of the limiting pin 3. Here there is a limiting pin 3. Using this limiting pin, the head will be butting here. Further, it will not allow to move further. So in this gap, the component will get ejected. Actually, in this gap, the sprue runner, whatever the entry material which is allowing to reach the 4, this is the 4 cavity mold, will be ejected here. That's what we call it as a 3 plate mold. So 2 daylights has been created. So finally the answer is you have to measure this face to bottom face. This height you have to enter it as a value. This is the answer. For this, I think I have created a short PPT also, small PPT. So where exactly how the guide pillar should be there. Then the limiting pin 1, 2, and actually the limiting pin 3rd one is not been shown. So between this and also one limiting pin is there, that also need to be addressed. Okay, so this is how you have to calculate the maximum mold distance. I know this is a bit tricky, but you should understand what is theory part of a 3 plate mold. Then you can, if you start, I think I have done mold, which means I have made some 7 to 8 components. That's all, not more than. Only 3 plates I adjusted, then 7 to 8 small components I adjusted, then the mating is done. Within like 5 to 6 minutes you can do this process once you practice it continuously. Just see if any questions. Okay, so for no questions, we will move further. The next question is also a 20 marks question. This is also a 20 marks question. The people who can able to do the first question can able to do this 5th question easily. So the first question, we found only one single component where we assign the shrinkage rate and we find the weight of the component. Yes, in the 5th question, what they will be asking is, they will be asking you to create a component along with the sprue runner gate 4 components means 4 components, 3 components means 3 components, 2 components means 2 components, whichever the model you done, based on that you need to address the question. I will quickly take to that example. So with this we are completing 100 out of the entire 170 marks. If you can address till this, everything is a 20 marks question. That's why I'm taking some time and explaining you also. Still, anyway, we have some time, so I'm not rushing. So this is the mold has been given. It's a 4 cavity mold. How do I say it's a 4 cavity mold? Just make it transparent. You can see here 1, 2, 3, and 4 cavity is are there. So what should I do is they have asked me to create the 4 components at a time along with the sprue and runner. So as I told, this bottom part you see whether it's really red or not. Undo, just make it transparent to hiding. So this portion, much portion, I can completely suppress it off. Okay. And this is also everything is in inserts. Only thing I am worried about the runner and gates. So runner and gates are machined into the plates. These plates. So again, this pillars, everything I have to suppress it off. It's not at all required for me. I just hide this so that it will be easy for me to suppress these unwanted bushes also. And even the springs are not required, so I will suppress it. And the display is also not required for me, because through this there is no material is going to come in. And these pins, the limiting pins which we discussed earlier, and these bushes. So these pins are required. Why it is required? As I told you earlier, this pin as a profile. You can see here this profile, over that only the material will get filled. So this profile also need to be formed into the material so that the gap should be there in the component which we are going to form. Till here the component is, this is for the ejection pinholes. Okay, so even now the material will get formed here also, but to stop here, and that we have to remove it. That also we should remember. So I will show this component. So the same process, insert component, new part. People who missed during the first thing, now you follow the thing. Just go to corner rectangle or middle rectangle, whichever is convenient. I just, above that, I have to cover all the 4 things. That's the requirement. I made a mistake. This is my mistake, my bad, sorry, wrong. What I did is I selected this space, but actually the material will start from this area, from this point. From this point the material will begin. So I should start at least from here, and I have to cut and trim here. So once again I do go here, insert component, new part, select this surface. This is very important. If someone has missed, I will just redo it. This surface you select, or even the top surface you select also fine. Later on you can cut and you can remove till this surface. I'm selecting the inner surface. Why I am selecting, even people who don't know, remember now, no need to worry. We will come to know once the component is created. So I select this face, features, extrude bars up to surface and until the bottom surface you select. The same process, cavity. I select the entire thing, just Q OK. Okay, it's not taking the things. What I will do is I will select split is required, this is required. I just manually selected here. Some selection goes, this issue will come. Just give the selected body. This is a bit complicated, so select only body one. Exit it. Open the component. The first step what I do is I will cut and remove this rectangle portion. Sketch. Extrude cut only can do. Convert entities you do. Again convert entities. Features extrude cut up to surface I give. Till here I select. Okay. I have cut and removed. Then direct editing I go. Delete bodies I go. Whichever the free bodies, which is wanted thing, which is formed from the holes. I deleted it. Next, delete face I select. As we discussed, this is the ejection pin. This is not the part of the component. So delete and fill command I use. And deleting this ejection pins portion because it's not the part of the component. It's for the ejecting the component. The ejection pin was there, that area. Since I suppressed the ejection pins, this has come. That's the reason. Then the same thing, delete face I use. This area a little bit tricky. Just wait for a while. I'll come here. Before that, so these four components are ready. So once here, as I told, this will be the starting point. So just go to the front plane, draw one rectangle. So I'm not constraining since it's due to time constraint. So but make sure. So from here, the material starts, goes here and fills the component. So here the whole so direct editing again, delete phase I go. I can select everything together. As we know, this portion is also for just pulling the sprue. Then finally, shrinkage rate. Material is ABS, shrinkage rate. So the same thing, the material ABS PC I have given. Actually, ABS means that will be different. Better you have to select, go here and select ABS only. Shrinkage rate is given as 0.06. Scale 1.06. Since the value here they have given us, whatever the value has been given, just take that directly after that one. Then evaluate, measure the mass property and evaluate mass properties and take the values. Okay, and enter the value. That's how we have to address this question. So far we have seen 5 questions. The 6th question is injection mold cooling problem. It's very easy and simple problem. Quickly you can complete this. You need not to do anything. Here also a mold will be given. As we already discussed, why the mold cooling is done, because as I told, the plastic material, the polymer material will be heated in the barrel and injected in the mold, into the mold in a liquid form. So inside the mold only it gets solidified. When the injected mold is in a liquid form, the heat from the molten plastic get transferred to the mold. That mold will get increased. The heat will in the mold will get increased. That has to be properly dissipated. This dissipation, heat dissipation is done by means of uh, cooling, water cooling. The water will be passing into the mold, the cooling will take place. Here we are not doing any flow analysis. There is no flow analysis. We are just going to check, is there any blockages is there or not. If there is a blockage, you enter that particular number 1, if there is a blockage in water cooling line 1, just enter the 1, or blockage in water cooling line 2, just enter 2. If there is a blockage in 1 and 2, 1, 2, like that you have to enter 7, 1, or randomly whatever the number you find blockage, that number you have to enter. If there is no blockages or that it's completely fine, means you have to just mention it as a 0. So how to find that blockage, we have to see. As I told, it's a simple problem. The points given to this also very less. It's only 10 points will be given. I will move on to that problem. So likewise, the mold will be given to you, and there will be a quiz. Here you can able to see like 1, 2, 3, 4, 5, 6 numbering will be up to 13. So it also the numbering will be done. What you have to do is just take a section view. taking a sectional view and seeing it on the number one. This is number one. Number one, the whole water enters here and comes out. I don't see any blockage here. So one is completely clear. Likewise, I have to check for all the 13 holes. So it's clear. Next, I move on to the second hole. Slightly move it and I'll check here. The hole is completely through. There is no blockage. It's completely fine. It will work. So water goes in here and goes out here. That's the ideal condition. And I move to number 3. Number 3 is also combined. The same way I move to number 4. 4 is also fine. There is no blockage. Next I move to 5. So whichever the number the hole, because that alone you have to see. This hole is not numbered, so I need no need to worry about this hole. 5 or hole alone I have to move and I have to see. The 5th hole is this. 5th hole is also fine. Next is 6th hole. I just move to the 6th hole. 6th hole is also completely fine. 7th hole. Water can go here and come out. 8th hole. Here is little bit tricky. You can see that there is a cross hole also. So 7 and this is the 8th hole. So when I go take the 8th hole, the water goes here, comes here and goes up again. Okay, the same way again comes here, goes up here, comes here, goes up here, comes here, goes up here. So still I don't see any blockage. Okay, so proper sealing is done here. There is a O-ring grooves also given here. So water comes here. So there is no leakage through this gap also and through this also. So water coming and traveling through this way in a zigzag way. It's completely reversed the thing. So I just do one thing. Just now you imagine water comes here, enters here, goes downwards and goes here again. That is, this core has to be cooled properly and always exactly it gets cooled. So still to confirm it, what I do is along with this, the second section also I will take. Lines going or not? No, there is no parallel lines. Completely, it's clear. It is water can travel. So 8th hole is also clear. Likewise, I have to check. I am moving on to the 9th hole. 9th hole also completely clear. There is no blockage. I can see. 10th hole is also clear. And 11th hole. 11th hole is also clear. 12th hole, I can see that there's a blockage. Water goes here. There is no cross holes. Okay, so I'll confirm that. What I do is one more check I do from the taking the other sectional view. So I can see here the 12th hole has this side holes. So we should not come to the conclusion immediately. Water goes here, comes here, and water travels here this direction also. So once in this holds how the connection is, I have to check. I'll take section 3. So comes here, it has completely good. There is no blockages here. So 12th hole is also fine. And finally, I should come to 13th hole. 13th hole is also fine. So here the answer is 0. You have to enter the value as 0 directly because all the whole inlet and outlets are perfect. Okay, right? This is how we have to address water cooling problem. The next question is taper interlock component. Once again, problem where you'll be given with a component. You have to just download the part. You have to apply the material and you have to find the shrinkage. Quickly, we will complete this. A component will be given. So the process is the same. So it will be in the 4 segment. Question 7, 8, 9, 10 will be, you'll be doing with the same component only. The first question will be of 5 points because very easiest point. You have to just apply the material, apply the shrinkage value, then find mass. So we all know this. So just right click, edit material and apply the material. Then scale the part based on value. It is whatever the shrinkage value has been given, just take care. 0.05 has been given, so give that particular value. Then go to evaluate and mass properties, enter the value in grams. You'll get the direct answer. This is how the 7th question. 8th question will be, you have to continue with the previous part only. Whatever the scaled part as it is only you have to use. Now you don't need to add any draft. Generate the parting line. So parting line creation, we all know. Then shut off surface creation. Total shut off area you have to find, and this is also again, since it is repeating, the points they reduced. Same thing what I'm going to use. People who missed earlier, for them, I'm just going to the mold tools, parting line. Again, they have given the plane also, front plane and 1 degree. So actually for this, it should be a top plane and 1 degree draft analysis I give. So the parting line will get opened. If it's not selecting on its own, just select manually the outer edges. This will be anyway provided in the image. Parting line, where exactly to provide, how it will be, everything will be provided in the images. So I'm selecting the as a chain loop. Completely selected. Then just give the tick mark. Suppose I will show you one error. Suppose I missed to select one small edge. For an example, I keep it as open. You will be finding like this yellow color warning you'll be getting, which means you should understood that some portion of the parting line is not being selected. So you have to identify once it is completely closed loop, you will not get any warning here. That point also you just take care. So the parting line is done. Then the shut off surface. just clear selection you give. This set of surface area also they will be given in the question itself, which area you have to do the set of surface. So you need not to worry. Okay. Once the shut off surface is done, the very next step, parting surface we have to go. So the distance they will be given. The distance roughly now I will take 25 mm. The same thing, the manual adjustment we used to do, right? The same thing we have to do it here also. You just see those lines properly and select. So it only will show the hinge points. Only thing you have to properly drag and drop it. First you just try with tangent with surface. If tangent with surface is perfectly matching, then no need to go for this perpendicular tuple and manual changes. For me, this tangent to surface is fine. It's working good. So I will go with this only. So I get the parting surface itself properly. Now I have to measure this value of this parting surface area. And enter it as a value. That will be the answer for the question. Sorry, question number 8 is only the shut off surfaces. So sorry, you need not to go here also. You stop here only. Just measure this shut off surfaces value, whatever we have created. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10 faces whatever the total area, this value you have to enter. That will be done for question number 8. And question number 9 will be, you have to create the parting surface and a taper interlock you have to create for this. Taper interlock is nothing but angle you have to create for this. A 7-degree angle with 15 mm distance if they have given, just go to surfaces, use ruled surface command. Okay. Okay, tapered with vector. First vector, you select this as some vertical edges, then select the value. So the distance 15 mm, if they have given, means just give 15 mm, and whatever the angle they give, like 7 degree or 8 degree or 10 degree. Suppose 8 degree they have given, means take that 8 degree. It will be given in the question itself, so you need not to worry. Now I'll just quickly show how to do it. Later on you can practice because the time constraint. I have to take Q&A also. Just select the entire edges and finally knit it. Another 2 I will complete this and we will have a Q&A. I selected all the edges. Then this portion is a bit tricky. You need to maintain the same taper over here. If you see here, normal to view, you can see here, this is a taper, 7 degree taper I'm talking about. Even all the side, this 7 degree is applicable. So the same 7 degree you have to create here also. So just go to planar surface, select these two edges, you create it, then extend surface command you use, select here, up to surface you use, option use, select, sorry, I just delete this, up to surface, select this surface. You can see here it has been created. Then trim surface, we all know the trim tool. So select this, then keep remove selection you select, and select this and remove it off. So this is how you can create this. The same way you can do it here. Whoever missed that side can follow here, planar surface, selecting these two edges, creating a surface over here. Then extend surface I select this edge up to surface and select till this surface. Sorry, I am once again making a mistake. I should activate this and select till this surface. Once it is done, you can see that it has taken the same taper, whatever has been taken here. Then trim surface. I go here, select surface extend tool, I select this, and portion to be trimmed, select this and trimming here. Once it is done, knit the surface. So knit, then once again you can go to mold tools, tooling split. For that again you have to create one more surface over here by creating a plane at the exact this point and create one more plane. Then you can create the core and cavity. The mass of the core you have to give it as an answer. That is the question for 10th question. Okay, so with this, I will stop my session because another 5 minutes left. If there is any questions, please let me know. I will start answering. Thank you everyone for your patience so far. I hope it's a little long session. Still, thanks for waiting in the session and being with me. If there is any questions, please let me know. I'm open to answer. And Syed, if you want, whatever the practice examples I have used in the session, I can share with you. You can share with the team so that if they want to practice, also let them practice. And if they have any queries later on also they can reach out to me through mail or something. That's fine.
Sure, sir. I will do that.
Okay, fine. Yeah.
And you guys can ask questions to the sir while filling the forms.
So one question is, can you explain what is the draft angle? It's while creating the parting line. Okay, I will do one thing. I will share my screen again. What exactly is the draft angle? I will show you a quick example. I will take you to the paint only. That will be easy. So you have a component, for an example, a rectangular component. Sorry, I am not getting very quickly. Why exactly draft is required? That is the question. So a rectangular component need to be formed. So this area, the inner area will be core. This area will be core, where the steel material will be there. And this outer area will be cavity. Again, the steel material will be there. Suppose when you are planning to remove this component, suppose you are ejecting the component. If there is no drag, what will happen? It will be keep on rubbing. The whole area will be keep on rubbed during the ejection. So when you provide a draft, which is nothing but a small angle instead of a straight wall, when you are providing a small angle, so angle to angle, when it happens, a small portion when the ejection takes place, so automatically the gap will be created between the core and cavity. So easy ejection will be happening. So instead of continuous rubbing in the straight wall, can be completely ejected when there is a small angle, a draft will be provided in the core. So always, as I told, when the material shrinks, the components will get stick onto the core. So onto the core, a small, for easy ejection purpose, angle will be provided. They call it as a draft angle. Hope I clarified this answer question.
No questions then?
Thank you. Thank you, everyone. Thanks for your feedbacks. There are a lot of feedback, good feedbacks. Thank you, Raymond. Due to time constraint, I couldn't able to complete the entire session, but to the maximum extent, almost like 140 points we have covered. If you properly practice, you can able to achieve it. So as I told, for your practicing purpose, I can provide you the models also, whatever is being used in the today's session. Mr. Syed Safi Asmi will be sharing with you all in case if you need to practice.
Okay, sir. Thank you. Wonderful session, sir. Awesome. I believe everybody got
Thank
an
you.
idea for how the exams. I really like how you simply made it. It was really, you see, understandable. I know how much patience, determination it takes to present a session. That to an advanced topic like mold tools, mold making. Respect to you, sir.
Thank you.
Established
Thank you very much.
session on mold making actually. I hope
Thanks a lot.
everyone the grasp on most tools. Okay. Also, this recording will be shared on the Bevy platform. It's an automatic system. Tell the thing for you.
Yeah, sure.
Uh, for presenting this wonderful session. I present you this certificate of association. Thank you so much, sir. Good.
Thank
You can
you. Thank you very much, Syed.
make
Thanks a lot.
to your sir.
Sure, fine. Thank you. Thanks a lot, Syed.
It's my pleasure. It's my pleasure. Guys, your certificates
Thank you
are
all.
being
Thank you all
as
for
soon as
joining.
possible. Don't worry. You can continue, sir.
Sure, sure, sure. Thank you all for joining through globally from various places and being patient for last 2 hours. That's all from my end. Have a great day ahead. And thank you, Syed, for giving me a chance. And even I'm looking forward for many presentations from Hyderabad SolidWorks user group in future also. Have a great day.
It's my honor, sir. It's definitely my honor.
Okay. Thank you.
Okay. Let's end the session then.
Yes.
Thank you so much for
Thank
being here, guys. Thanks again, sir.
thank you. Thank you.
Okay.
Bye.
I hope everyone has filled the Google form.